Okay, we're going to review this. This is something you learned in elementary school. Okay, we'll start with an easy example. I'm going to give you two numbers, 6 and 24. 1 multiplied by 6 gives you 6. Is 6 divisible by 2, as you said? 2 times what gives you 6? Good. 4, is 6 divisible by 4? 4 times something give you 6? No. What about 5? No. So these are the only factors of 6. 1, 2, 3, and 6. 1 times what gives you 24? Good. Is 24 divisible by 2? Yes. 2 times what gives you 24? Good. Is 24 divisible by 3? Good. 3 times 8. How about 4? 6. Good. 4 times 6. So 2 times 12, 3 times 8, 4 times 6. What about 5? No. So see how I did it in order? If you do it in order, then you won't miss any factors. But what we're trying to figure out is the greatest common factor. Which factors do they have in common? They have 1 in common. They have 2, 3, not 4, there's no 5, and 6. Which one is the greatest common factor? So the greatest common factor equals 6. Okay, so that's how you find the greatest common factor, which is what you need to do today to factor an expression. So, okay, so this section is on something called common factoring, and it actually relates to what we did yesterday. Because what is the definition of factor? What does it mean to factor? Can someone read the definition in the book? Okay, so to factor means to express a number as the product of 2 or more numbers. So for example, if I give you the number 10, can you express this as a product? What times what would be equal to 10? Okay, 2 times 5 is equal to 10. Does everyone agree? Are there any other numbers that you could multiply together that will give you 10? 10 times 1? Good. These are called factors of 10. 2 numbers that multiply together to give you the answer. Okay, so now I put a variable in the mix. First, let's look at the numbers, the coefficient. What is the greatest common factor, GCF, of 10 and 15? So I need you to write out numbers 10 and 15. Good, how did you get that? 1 times 10. Does 2 go into 10? 2 times 5? Does 3 go into 10? 4? 5. We already got 5. Okay, what about 15? 1 times 15. Does 2 go into 15?
3 does.
3 times what? Good. 4 and 5 we already got. So, as you said, what is the greatest common factor? The greatest common factor of these two terms is 5. But both of them have, one of them has an x squared and one of them has an x. So, what variable can they both be divided by? What do they have in common? 5. And what is the variable that they have in common? X. Whenever there's an exponent, you always want to look for the exponent that is the lowest. So this is to the power of 1 when there's no number. They're both divisible by x. I cannot divide them by x squared because this one only goes up to the power of 1. If we divide it by x squared, which is higher than that, it's going to give you a negative number. So we can start with the numerical part first. We have a 6, a negative 12, and an 18. So what is the greatest common factor of 6, negative 12, and 18? Is it true that all of these are divisible by 6? Yes. Okay. When there's a negative, if one of the terms have a negative, this is important, I want you to factor out the negative. So I want you to include the negative. All of them can be divided by negative 6. Okay, whenever there's a negative, you want to make the greatest common factor a negative. Now, let's look at the variables. We have x to the power of 3, x to the power of 2, and x, if there's no exponent, it's to the power of 1. What can I divide all of these by so that I won't get a negative answer? What is the common variable? X. Okay, I can't divide this one by x to the power of 3 because 3 is higher than 1, so it's just x. So the greatest common factor is negative 6x. Does that make sense?